With the increase of Internet of Things devices, the amount of data being stored will increase as well. Analyzing the data in the conventional way isn't always ideal for that. This is where deep learning comes into play. Deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural networks. Deep learning has been around for a long time, however lately it experienced a large boost. In this explanatory video, we will elaborate the basics of neural nets, their uses, and what we expect of the future of deep learning. As you can see, deep learning can be used to predict poker hands. Casinos do something similar. They check for cheaters with specialized software. Another common example are parking spaces with automated gates. These gates only let vehicles of employees through. They do this by analyzing a made picture of the license plate and extracting the license plate number as text, and comparing this to a list of verified license numbers. Both examples are about cameras analyzing images made by embedded devices. In the early research stages of neural networks, the 70s, when research into neural networks was still in the infancy, the main problem of neural networks was that they couldn't input data in their raw form. Because of this, the implementation of deep learning networks needed to consist of two parts, a feature extractor and the neural net itself. The feature extractor would be made by engineers that had specific detailed domain expertise. They took raw data and created so-called feature vectors, which is a vector containing all the important aspects of the raw data. The neural networks would process these feature vectors, assigning each of them to a best-fitting classification. For example, classifying the characters of the license plate into actual text. However, a significant difference of neural nets from back then compared to now is that current neural networks don't need this feature extractor because it is included inside the network. The network consists out of multiple layers. The input of each layer gets abstracted more and more when going into the neural network. However, having more of such layers does need more time to train. The training is done to improve the solutions of the neural network. The training can be done in two ways, supervised or unsupervised. Currently, most networks are trained using the supervised method. This is mainly due to the fact that at the moment, this seems to be the most effective approach for classification networks. To apply supervised learning, you don't need much. Just a large input sample set and the expected output for each of the inputs. A typical neural net gets fed input, calculates the output, compares it to the expected output, and then adjusts itself. Before we explain how a network adjusts itself, we will first explain how the typical neural network works.
A neural network consists out of multiple layers among which are an input and an output layer. Initially, the nodes inside of the input layer will be set to the value of the input. The input layer is then connected to a so-called hidden layer. There can be multiple hidden layers in a neural network. Layers inside the neural network are only allowed to connect to adjacent layers. The last hidden layer will then be connected to the output layer. There are different ways to connect the layers, however, in the majority of the cases, all nodes of one layer will be connected to all the other nodes of a different layer. In most cases, each layer will do the abstraction for some feature. When the neural network is given an input, it will adjust the value of the input by doing some computation with the weight of the edge and the input value. Then it will combine all the incoming edges of a node to calculate the value of that node. This will be done for all nodes. The output nodes will then have some specific value, usually a percentage. In a classification network, this percentage reflects the chance that the specific input falls into a respective category. Now that we know how a neural network works, we can go back to training a neural network. There are multiple ways to apply supervised training. One of the most well-known methods is backpropagation. Backpropagation is a method used in artificial neural networks to calculate the error contribution of each neuron after a batch of data is processed. With backpropagation, you give the network some input from the training set. The respective output is then compared to the expected output. Subsequently, a modification vector is calculated. This modification vector will contain information needed to change the value of each edge, which can be used by the network to adjust its settings. Those changes can be quite small, which is a good thing, otherwise it could overfit the network for one particular case. The second neural network that we will discuss are the deep feed-forward networks. With deep feed-forward networks, the network is forced to have each layer abstract a certain feature. Pre-training is done on several layers to train the layer for some specific feature. This way, the layers are initialized to sensible values. Now, we have multiple components that each recognize a certain feature. Those components are combined into one regular neural network, which uses backpropagation to improve even more. Deep feed-forward networks are mostly used in cases where it takes a long time to train a network, or when the network cannot recover from previous mistakes anymore. In combination with recent developments in faster GPUs, deep feed-forward networks were a breakthrough for speech recognition models. There is, however, a more specific network that is used in devices like Google Home or Amazon Alexa. That network is called a convolutional neural network. This network is specialized in processing data which consists of multiple arrays, like images or sound. The first few layers are separated into convolutional layers and pooling layers. The convolutional layer is designed in such a way that it will look for local patterns. Next to that, when it has recognized a pattern, it is capable of finding that pattern in different positions of the image. The pooling layer will then merge similar features into one. Just like in a regular network, convolutional neural networks can have backpropagation during the training to improve themselves. The last network that we will discuss is a neural network which has streams as input. Think about autocorrection or word prediction functionalities on your mobile phone. This type of neural network is called a recurrent neural network. The reason why it is so special is that it keeps track of a state vector in its hidden nodes. This state vector contains information on all previous inputs for that particular sequence. At the end of the sequence, it will do backpropagation to improve itself. This may not seem too impressive at first, however the following two examples will show you that it is quite advanced. The first example is about the translation of human languages. Recurrent neural networks can be used in translations as follows. There will be two neural networks. Firstly, there is an encode network, which will take, for example, an English sentence. This sentence will have been stored in the internal state of the recurrent neural network. This internal state is then copied to a second network. The second network is a decoding network, which will translate its inner state to, for example, a Dutch sentence. Now, the second network will show a distribution, the chance for each possible word to be the intended word. When the user actually typed or selected the first word, it will continue to give the chances for the second word. This will then continue until the entire sentence is translated. This form of translation, even though it seems to be a very naive way of translating, did actually come very close to state-of-the-art translation methods. The second example is a combination between the convolutional network that we have seen and the recurrent neural network. You feed the network an image. This image will be analyzed by the convolutional network. The output from that will be used as an input to the recurrent neural network. The recurrent neural network will then translate that output into a correct sentence. This might turn out to be very useful for making indoor cameras distinguish between your pet walking around the house or a burglar breaking in. Now, what do we expect from deep learning in the future? Interest in describing images like the license plate reader have increased significantly. Therefore, we expect that those will improve even more. We also expect that recurrent neural networks will improve in understanding natural language, since a lot of devices like Alexa or Google Home are being produced. The data that companies like Google or Amazon can harvest from these virtual assistants could be used for training the networks, improving them even more. However, the biggest improvement is expected to be in unsupervised learning. We didn't discuss this in detail in this video, but that is mostly due to the success of supervised learning. Unsupervised learning will be more useful in discovering and exploring, since it depends on learning by observation. This could, for example, be used to improve robot vacuums or even self-driving cars. Self-driving cars would then over time learn to adjust their driving style to its surroundings.